Yesterday I was talking about some of what's going on in the world. Today I'm really talking about what I've been doing in Kenya, and I'm afraid it's not quite as impressive as the previous speaker, but I hope it's relevant for computer-based maths, and I hope it's relevant for actually looking about what computer-based maths might become. I should just mention that, because a number of people asked me about this, the EPSRC platform grant is how I managed to come to the UK, that I was actually in Oxford for the past 10 days doing maths research, and that allowed me to be here at the conference, so I should offer them recognition and thank them for that. I guess the real aim of my talk is to try and say that I really think that maths and stats in Kenya could be a good place to test reform. And I am talking about this radical reform of really saying, you know, let's start from scratch and build a system from the ground up and think what needs to be done. And I think we've heard from examination bodies about, you know, the fact they're very keen to sort of make changes and so on, but it's a slow process and it's a difficult process, and you need to be careful because the system in the UK is turning out people who are successful. And so, you know, you can't just make big changes just like that. And I think a system like Kenya, changes can happen much faster, and this can be somewhere where what we learn might well apply back and be able to give us some of the data that we need to be able to bring some of these changes, for me, home. So this changed a bit, but this is something which has come out of the talk earlier, and it's something I've been feeling quite strongly, that there are two key groups that need to be engaged for the computer-based maths syllabus. And this is why when I'm talking about a plan for Kenya, I'm not talking about a plan for computer-based maths, because it doesn't include two of what I feel are the really key components. It doesn't include enough engagement with statistics educators. I'm not talking about statisticians here, I'm talking about statistics educators. And my reason for that is very simple. When I show it to statistics educators, when I show the ideas of computer-based maths to statistics educators, they say, that's all very nice, but we were talking about this 30, 40 years ago. This is what we've believed for the past 30, 40 years, and we've made some progress on this. You know, we haven't solved everything. It's a difficult subject area. It's difficult. But progress has been made. We should maybe engage more with them and learn from that. And the second thing is actually mathematicians. And I'm wanting to include pure mathematicians that often get sidelined in this. That I do believe that there's a good positive relationship here, and it's not being built. And if it was built, things could move better. So those are two key groups that I think could help computer-based maths as a concept really grow. But what I'm really here to talk about is a bit about the work I'm doing. And so I've got a number of projects which are going on. Some of them are in the present or the near future or the near past. And then I've got three big ideas which I'd like to talk about, which relate to what I'm hoping could happen relatively quickly in Kenya, and I think would be relevant for computer-based maths. But I'll start with what's led me here. And it really started with the fact that when I first arrived in Kenya, I was asked, you know, I'm a pure mathematician, and there was a statistics student who was told they would have to go home for 6 months because there wasn't anyone to teach them. And I said, well, I could teach them a course if I had to. And, you know, probability theory, that's actually just measure theory with sort of fairly specific things. So if you're wanting a good, rigorous probability theory, you know, I could do something on this. And I started teaching, and I realized that this was the wrong thing to be teaching. And so the course transformed into something which was really very computer-based, very practical, very applicable, trying to get some of the skills across that my student as an applied statistician would need. And that led me into a number of ways of integrating computers into teaching applied statistics, which I think is relatively uncontroversial. This is something where nobody has any doubt that we should be doing applied statistics using computers. And that's really where, in some sense, my journey on this started. The reason I put Strathmore Conference here is this is sort of something we've got going on every couple of years. We organise an event in Kenya, and Michael was there 2 years ago, and presenting on computer-based maths. And this is something where it is something part of what we're trying to build up in Kenya, that there needs to be a culture around not just computer-based maths, but maths in general. And that needs to be built from the ground up. And the conference is part of that. So from the teaching of this one MSc course, I then got involved more and more, and some of my students were then employed by the department, and they became lecturers. And they wanted to teach in these new ways, and so it then became very natural that part of what I was doing was also trying to get them to integrate some of these ideas into their teaching and to understand not only how to learn like this, but also how to teach like this. And so that seemed a very natural next step. And really, further on down there, we've interacted with international research organizations, and part of what you're saying about what's needed, this data management, the applied statistics program we were teaching, however well we were teaching it, wasn't the right program. It wasn't preparing people for the jobs that were really needed in the research institutes. The research institutes, CGIAR centres in particular, were crying out for people to help support research and help support researchers to do good research. And that required a whole range of skills, some of which were applied statistics, but others were more data management and other things like this. And so this was sort of an idea which came out of a number of people working in there, and we've tried to implement it. And we've run into difficulties, but the basic ideas, I think, were solid. And this is sort of also part of the fact that we're then sort of saying, well, okay, in Maseno's within Kenya, it's one of the 7 public universities, and it tries to differentiate itself by saying everything is taught with IT. It doesn't matter what you're learning, it is taught with IT, because computers are such an important part of Kenyan economy and the future looking forward. There are difficulties of infrastructure. Taught with IT doesn't mean you actually have access to computers. So that is an issue because the infrastructure isn't in place. So being taught IT on pen and paper isn't as useful as it would be if there were more infrastructure. But the principles are there. And we've been trying to integrate statistics into the IT curriculum to try and get these ideas of data management in there, to try and get these skills that are needed out in the workplace for researchers of all types into the undergraduate curriculums. What sort of also came out of this original idea of teaching MSc students applied statistics is some of those students were teachers. And they said, we have statistics at schools, and we're not teaching that very well, so why don't we use these same ideas that you're bringing in at university into schools? And so some of my students sort of said, we want you to come and we want to work with you to try and present these to teachers. And this was this part of the SEMASI, which is a big initiative where all teachers in Kenya are trained. And so we gave the first computer-based SEMASI training, where we tried to just introduce people to a bit of what we were doing at the university level, so that people had access to some tools. And that worked relatively well. But we recognized that the real issue is to get down to the students. And I think you heard about the Maseno Maths Camp yesterday. Maybe one of the points to bring out of this, there's 2 little anecdotes here. One is one of our students at this last camp, I think you heard that they were taught projective geometry as one of the things that they were presented with. And one of the students not only took that to heart, but is now pestering us that in his school holidays he wants to come and learn more projective geometry because he wants to go to MIT when he finishes his school degree in Kenya. An incredibly bright kid, just needed some inspiration and now has found some inspiration. The second example of this was a young girl who we got in. So her mother got in touch with one of my students who's helped organise this, and said, what did you do to her at maths camp? She spends all the time at her neighbour's, because her neighbour has a computer, and we gave her a DVD with some resources on, which were free, and she spends the whole time there on the computer using the resources. She then took the DVD to her school, and her school got in touch with my student, who said, what did you do to her? She now raves about maths and is the top maths student in the school. Can you come and discuss with us? So we went and discussed with them. We showed them the software. We explained it was all free. And they said, well, can you do the maths camp here? And we said, well, it's actually quite a lot of work to do a full week-long maths camp. We don't have the resources. We can't do this. What we can do is we can come in for half a day. And so that's what we've tried to start. We've sort of, schools can now apply and we'll do a mini maths camp. We'll go in for half a day and just see if we can try and shake up a bit what's happening in schools. The last set of mini-maths camps presented this idea of programming without computers, so that we just give people very simple instructions: go forward, turn left, pick up, put down. Notice there's no turn right. So if you need to turn right, you have to figure out that you have to turn left 3 times. So it's simple things like this which actually get people to think about a limited syntax, get to think about what it means to follow the rules and actually have a structured thinking. And it's been very successful. It's worked quite well on a small scale because we don't have the resources to do this. We don't have the manpower. But it has helped us to sort of solidify some of the ideas and to test out some of what we feel the change needs to be. I should say that Bahir is a university in Ethiopia. They sent a representative along in August this year, and in February they're going to try and give their own maths camp. We're still discussing whether we can go and support them and actually send someone, but irrespective of whether we go or not, they're going to go and try and do it. And this is sort of part of what we hope. We can't do everything ourselves. We do have a growing group, but it's a small group. And so having other people come and just take the ideas is what it's really all about. So now let me actually move on to what I think we need moving forward. So the first one, which is maybe in my mind the most important, is I feel that in Kenya, none of my MSc students really are full-time. It doesn't really exist as a concept. Now, just for those of you who are mathematicians, try imagining doing a pure maths MSc part-time while you're a teacher. I mean, this isn't something which fits in with our good education concepts. Most of our students are teachers, and we therefore think we need to devise a program which is appropriate for teachers and really engaging to teachers. And we're sort of honing in on sort of 4 areas. I've labelled one of them computer-based maths because it's appropriate for here, and I think it's in line with that. That's not what I'd normally label it, but I think it really is the idea that's at the heart of this, and trying to get to, at a slightly higher level, people being able to really use computer-based maths is an appropriate one of these 4 topic areas. The second being mathematical reasoning. By that, I'm really thinking about, trying to get people to be able to understand the language of mathematics and the value of having this sort of language. The third one is research methods. This links in with this idea that we need people who can do research and support research, and we need people to understand what research is. And because it's about the high-level data literacy, if you want, that's so needed in the society. And the fourth one I've put as a rather lame teaching mathematics. And the idea of this, if you remember the name of it, it's really about maths innovation. This is about trying to use innovative ways to teach mathematics. So that would, in my mind, include things like both computer-assisted maths as well as computer-based maths as a component. And it would also include areas of mathematical teaching which don't need the computer. But it would really be about trying to get people not to research, not to study maths education about how to teach maths, but to be able to innovate when teaching maths and to do it in different ways, to give them the tools they need to be able to move forward and to be able to make changes. And I feel alongside that is something where in Kenya there are all these students who fail maths. If we believe that computer-based maths can make a real difference in people's lives, then these people who are failing maths, maybe we could actually devise a diploma which would sort of be almost a bridging program so they can now get to university. They couldn't have got to university before because their maths mark was too low. They can do the computer-based maths. This gives them a certificate they need that they could now attain university, maybe. But more than that, this might make them into really, have a useful skill set, which could then lead to jobs and lead to employment. And so if computer-based maths is going to make that sort of difference, maybe this is one way to test it out without the risk of testing it out in schools. Because this is something where we could have an intensive 1-year course with students doing something. It's an idea, and I think it's something which a lot could be learnt from it, about designing a curriculum, which would be useful and which would have good outcomes. I don't know what would be in that yet, but I have some ideas. And then tablets in schools. So my 5 years in Kenya has been a time of great change for technology in Kenya. And Kenya is heralded, rightly or wrongly, as a great advocation for how much technology can penetrate and can do in a developing environment. And the innovation, some of you might now use mobile phone banking. And this really, Kenya was incredibly innovative with this, with their M-Pesa system. And so I don't know if any of you have heard of that, but this came out of the fact that people were buying phones, giving them to their family and sending their family back to the village, and they lived in the big city, and they would buy credit for the phone, send the PIN number for the credit back by text to their family would charge the credit, and then lend the phone to other people and sell the credit in that way. And this would be a way of transferring money from the city to the village. And, you know, the mobile phone company cottoned on to this and said, well, why don't you just transfer money through your mobile phone? And that's what they did. And there's now sort of banking through the mobile phones is really taking off in quite a big way in Kenya. Now, arguably, the penetration of mobile phones is recognized as being great, and the penetration of other technologies isn't so great. And tablets are sort of halfway in between, because they sort of have the same power requirements as a mobile phone. So if you can charge a mobile phone, you can charge a tablet. You can't necessarily run a computer. So if you can charge a tablet, then the question is, can we get them at a price point which is able to penetrate into schools? I don't know if this is true, but we're trying to test this in a school. We haven't quite got we've got as a proposal in with a few different people, but we don't know if we're going to be able to go ahead with it yet. The idea is very simple. The idea is that as a 10% increase in school fees, even in the poorest schools in Kenya, over a 4-year period, a child could pay up to about $60. That would correspond to 4 years' worth of 10% increase in school fees. And parents would be willing to pay that. So theoretically, we could get a tablet to every child for a 10% increase in their school fees. Can we produce tablets that are reliable enough for this? Why are tablets important? Because there's no barrier to actually using them. They're really very easy. There are many initiatives trying to push for tablets at that sort of price, and they exist on the market. You can get tablets from China. Whether they're reliable or not, that's another question. But it is something which is possible and certainly achievable. And I wonder whether we can test this out. Now, there's also issues of what software will run on the tablets, and that's a whole different issue. But I think the technology is almost there, and I think once it's there, it will become ubiquitous. And I think we've got a rural school, which is a very poor school, a girls' school, where they don't have power, but they do have enough solar power that they could charge tablets. So they're not connected to the grid, but they have a little bit of solar power, and that might be enough just to charge tablets. And so our aim is to sort of try and kit them out. They've got a couple of Peace Corps volunteers. We want to kit them out with tablets while the Peace Corps volunteers are there, see if they can be integrated into the learning, and get them to all the kids there and see what happens. It's just as a way of testing this. And the aim is to measure this against the high school results. We're not trying to change the system there. I should clarify, we are trying to change the system across all levels. That's what we want to head towards. But you don't start by changing everything at once. You've got to start by actually figuring out what you can change and how. And I think in Kenya, most of the components are there. The government wants to find ways to get technology to everybody. And they're putting money into it, not huge amounts, but enough that it might be viable. That's really where I want to end.